Good morning, guys. In this video, we'll start a new chapter, chapter 6 in statics, which is the structural analysis. In this chapter, we'll talk about trusses and frames, and we'll talk about the methods to solve for trusses and for frames. Now, what is required for you for the test that will be held next week is only the first method for trusses, which is the method of joints. Now, guys, let's start by explaining or by defining truss. What is a truss? Basically, a truss is a structural body that is composed of slender members. So, some slender members joined together at their end points by pins. So, I have some slender members that are joined at their end by pins, and they are basically used to handle the roof load. They are used in the bridges, they are used in the towers, so they are basically used in order to handle some load above them. What I want you to know that the slender members in the truss are two force members. What does this mean? Go back to the video of the two force members. Basically, guys, the slender members are two force members, which means that the forces at their end are only axial, so they have the same direction of the member itself. Because I know from two force members that if I have equilibrium, these two forces should be in the same line of direction, which means what? Which means they are axial because I have here a slender member, and axial means along the axis of this member, and they should be opposite. We'll talk about this later on. Now, guys, I want you to recognize first of all the difference between truss and frame. In the trusses, guys, I don't have any force on the member. So, guys, if I draw here one member of this truss, so if this is the member of the truss, and of course it should be pinned at the end with other members. Now let's take this member and separate it from all other members. If I have a truss, I should not have any force on the member, any external force on the members. All my forces will be basically at the pin or at the joint. So here we call the pin a joint. So they will be at the pin or at the joint, and they should be axial because in fact, guys, they should be axial because in fact this is a two force member. So for trusses, guys, unlike the frames that we'll be talking about later on, I don't have any force on this slender member, because if I have any force on the slender member, this will not be called a truss, and the member itself will not be a two force member. So this is what I want you to know first. Second, guys, I want you to recognize the difference between a tension and a compression. So if I have this member here, and the forces in this member are, of course they must be opposite in order to conserve the equilibrium, are out from this member. This is what? Is it a tension or a compression? I have a tension. Now in the other case where my forces are into this member, then this will be caused compression. So this is the difference between tension and compression, and this is the second thing that I want you to remember. Okay. Basically, guys, what matters for me is the equilibrium of this truss. And in order to have some equilibrium, because in fact this truss will hold some load from the roof or from the bridge or from the tower, this means that this load does not have to cause any motion for this truss in order to be in equilibrium. And this, guys, will be basically afforded by some reactions at the truss. Okay, so I have some reactions that will prevent this translational motion, and this is of course will be afforded or provided by what? By some supports. So usually, guys, in the truss, like this figure here, so as you can see, this truss here has two supports. So you can see that this is a pin support and this is a roller support. So I usually have two supports for a truss. They could be two pins or one pin with one roller, depending on the loads. Now, guys, what I want you to know that I can have also some other external forces, but as we said, these external forces should not be on the member. No, it should only be at the joints. Okay, like this case here. So I have some external force, of course, caused by the weight of the bridge or of the rooftop, and these external forces, guys, are exerted at the joint. And from here, guys, comes the difference between truss and frame. Now, guys, I want you to know that the trusses are always modeled as a 2D case. And this is because, guys, the members of the trusses are slender. So I can assume that I am in 2D case, and then I can solve my equilibrium equations. So what are the assumptions in designing the truss? First of all, as we said, all the loadings are applied at the joint, and this means, guys, that even the weight of the member, because I know that the weight of the member, if I need to draw the weight of the member, it should be at the middle point of this member, and this means that they are not at the joint. So even the weight of the member is neglected. So I will not talk about the weight of the member, because if I add the weight of the members, this will no longer be a truss. So usually in the truss, the weight of members are neglected compared to what? Compared to the external load that this truss is holding. And the second assumption is that the members are joined together by smooth pins, and this is basically in order to assume that the forces, if I have two members here, so this was, let's say, the second member. So if I have a pin here, then the second assumption states basically that the second force, which is developed in the second member, is also intersecting this force by this point, which means that all the forces on the joint are concurrent. So these are basically my assumptions, and I will start basically by explaining what is the method of a joint. Now, guys, the simplest form of truss is basically the triangular truss. So in the triangular truss, I have only three members, three slender members. So let's take this example in this figure. So you can see that this could be assumed as a truss, because in fact all the forces are on the joints. Here I have two forces because I have a pin, two reactions. I have one reaction here because I have a roller, and at C I have one external force. Now, how to do the method of the joint? First of all, guys, let's focus on the objective of this chapter. The objective of this chapter is to find the internal force inside the members of the truss. So basically, I need to find these forces right here, the tension or the compression forces that are developed inside this member, the member of the truss, in order to handle or to hold this weight, the weight of the roof, of the tower, or of the bridge. So basically, this is the main objective of this chapter. So I need to know the force in each member, and remember that these forces are internal if I take the whole truss as my free body diagram. So basically, guys, if I take the whole truss as my free body diagram, the only external forces are the forces that are outside, caused by the rooftop or caused by the bridge or caused by the tower, as well as the reactions. For example, if I have a pin support or if I have a roller support, all the forces inside the members will be internal if I take the whole truss as my free body diagram. So basically, guys, if I need to find the internal force developed in this member, I could not take the whole truss as my free body diagram. Now, of course, guys, in order to find these internal forces, I should apply one of these two methods that I've talked about. The first one is the method of joints, and the second one is the method of cut. Now, in the method of a joint, what you have to do, you have to take the joint itself, one of these joints inside the truss, and you have to make this joint as your free body diagram by illustrating all the external forces acting on this joint. And then, guys, by drawing all these external forces, I should apply the equilibrium equations. Now here, guys, since I'm saying that you should take this joint, let's say this one, this joint, and show all the forces exerted on this joint, then this means, guys, first I am in 2D case, so I only have two equations for the forces. Sum of fx is equal to 0 and sum of fy is equal to 0. And second, I don't have a moment equation because in fact, as I assumed in the previous slide, all my forces are intersecting this joint, which means I cannot use the sum of moment. It is useless because this will give me a trivial equation of 0 is equal to 0. So basically, guys, in the method of a joint, the steps are: 1, I should take a joint, and guys, pay attention here in the first step. You should choose the joint that has a maximum of 2 unknowns because I only have 2 equations here. Second, show the free body diagram by drawing all the forces on this joint. And what is surprising here, guys, that now if I take this joint and draw all the external forces, in this case the internal forces of the members, like this internal force here, will be external for that joint. And this, guys, and this is how I can solve for these internal forces. 3, apply 2 equations, and that's why, guys, the truss is very easy because in fact I only have 2 equations. The sum of fx is equal to 0 and the sum of fy is equal to 0. So this is how I can solve any truss example, by only doing the 3 steps. First of all, I should choose the joint that has the minimum number of unknowns. Second, I should draw the free body diagram by drawing all the forces on this joint. And third, I should apply sum of fx is equal to 0, sum of fy is equal to 0, and then I can find the internal forces. Internal forces of what? Of the members joined by this joint. And then, guys, I can take another joint and then do the same thing if I need to find all the internal forces. This should remind you by electricity, by the Kirchhoff law that states that all the current in is equal to all the current out, or in other words, the sum, the algebraic sum of all the currents is equal to 0 at each node. Okay, so it is the same here. You put your joint, you put all the forces, and you know that the algebraic sum of all the forces in x and y should be equal to 0 in order to reach the equilibrium, and then you can solve for your 2 unknowns. So I only have 2 unknowns. I cannot have more than 2 unknowns. If I have more than 2 unknowns, this means that I should start by another joint in order to solve for this problem. So this is the explanation of the first part of this chapter, the method of joints. Let's now solve problems. Thank you.